To start with, we're going to work with the unit circle.
Should we grab rock, paper?
For this, nah. Oh, that messed a little bit. Alright, you get the idea.
That ain't no circle.
Okay. So I got 1, 0, 0, 1, negative 1, 0, 0, negative 1. So this is my unit circle. The reason this is called a unit circle because it's a circle centered at the origin with a radius of 1 unit. Okay? The radius is simply 1 unit long. How can you tell? Well, here's the center. From here to here, that's 1 unit because that's the coordinate 1, 0. Right? Okay? 1 unit long, 1 unit long, 1 unit long. So it's called the unit circle because the radius is exactly 1 unit. Alright? We're going to come up with the equation for this unit circle. Alright. Obviously we know this coordinate right here is 1, 0, that's 0, 1, negative 1, 0, 0, negative 1, and so on. Okay? Let's pick a coordinate right here. We don't know what that coordinate is, right? We can maybe guess, we can approximate. But that coordinate definitely has some x value and some y value, right?
Mm-hmm.
Okay? Now I'm using that coordinate, I'm going to make a right triangle. So I'm going to go straight up. And I'm going to go back to the origin, and by doing that I've created a right triangle. Everybody see that? Yeah. Okay. I know all 3 lengths of that right triangle. But 2 of them are in terms of a variable. If this coordinate right here is x comma y, how long is that side of the right triangle? X. How long is this side of the right triangle?
Y.
Y, right? Because if this is the coordinate x comma y, we went x units this way and then y units this way to get there, right?
Mm-hmm.
So I know that this side of the right triangle is x, this side of the right triangle is y, and how long is that side? 1, because what is the radius everywhere inside this circle?
1.
1. So that's x, that's y, that's 1.
So then x squared plus y squared would equal 1.
X squared plus y squared equals 1. That is the equation for this circle. What did he use to come up with this x squared plus y squared equals 1? Pythagorean theorem, right? And that's okay to use the Pythagorean theorem because we have what type of triangle?
Right.
A right triangle. Good. Okay? So, x squared plus y squared equals 1. That is the equation of the unit circle. Now, obviously, there's a lot of other circles. We can't just have all of these circles. They have a radius of 1. They're centered nicely at the origin. Okay? But the unit circle is x squared plus y squared equals 1. Okay? So, knowing that, x squared plus y squared equals 1. That is the unit circle whose center is at 0, 0, and whose radius equals 1. Right? Everybody agree? The unit circle, the center is at 0, 0, the radius is 1. Okay? Would you guys all agree that this is exactly the same graph right here?
Yeah.
Because isn't x minus 0 squared still the same thing as x squared?
Yeah.
And y minus 0, so on. Okay? So these are all the same. The center's at 0, 0, my radius is 1. Guess what this circle looks like? What do you think that circle looks like?
16 up.
Not quite. Center is 0, 0, that's correct. Be careful, the radius is not 16. Noah?
4?
4. Yep.
Because it's square.
X squared plus y squared equals 4 squared.
Oh, geez,
Okay.
what a guess.
So my center is still at 0, 0, and my radius is 4.
Shut up.
Okay? You with me? You with me? Yes? No?
Yeah.
Okay? Alright. Okay? How about this one? X minus 0 squared plus y minus 0 squared equals 81.
9.
Center is at?
9.
No.
No, no, the center's at 0. 0.
Look, guys, look right here at this one. When I asked a couple seconds ago, do you have any questions on this one? How can you not notice that the center would still be at 0, 0? I haven't changed anything there. The center is still at 0, 0, right? Okay, what's my radius though?
9.
9. So my center would be at 0, 0. My radius would be 9. You see that? Okay, now I'm going to change a couple more things. Keep following with me here, okay? And stop me if you don't understand something. I'm going step by step for a reason. What do you think about this? Center's at 2, 5. Center's at -2, -5. Okay, I can see that. And what's the radius? 2. You're right about the radius, and one of you was correct about the center. The radius was 2. The center is 2, 5. Okay? Because those are the values that make each factor equal 0 in a sense. Those are the values that would essentially get you back to the origin if you think about it.
Back to square
Okay?
one.
Back to square one, kind of. You can think of it that way. Alright? Think, what value of x would give me a 0 here? Positive 2. What value of y would give me a 0 here? Positive 5. So my center is at 2, 5 in this instance. Where's that center? What is that radius?
1, -3, and 7.
Center's at 1, -3. Agree? Disagree? Don't understand?
I agree.
Okay. Center's at 1, -3. What's my radius?
7.
7. Center's at 1, -3. My radius is 7. Okay. Do I have you all with me? Anything you're not quite following? Last one. Center's at AB. And my radius would be
R.
R. Good job. Okay? So that would represent any circle. Okay? This could represent any circle. Whatever A and B are, that is your center. Square root this, that is your radius. You can use this to help you graph and write any sort of equation for a circle. Okay? Well, real quick here, if I said to graph x minus 3 squared plus y plus 1 squared equals 16, how do you think I'm going to do that?
Go 4 up and 4 to the right.
What do you think you should find first?
3 up, 1 to the left.
You graph the coordinates for 3.
I'd find the center.
Yeah.
Where's my center?
-3, so to the left.
Three.
1, 3.
3 negative 1.
3, -1. My center's at 3, -1. There's my center. What's my radius? 4. So what I would do is I would go 1, 2, 3, 4 to the right, 1, 2, 3, 4 up, 1, 2, 3, 4 to the left, 1, 2, 3, 4 down, and do your best to draw a nice pretty circle. Probably do better than what I do.
Oh boy.
I keep missing on that side.
It was close. I think the configuration's off. That's fine.
Yeah, I'll blame it on that.
You draw it back.
Okay?
You know what that looks like, Chris?
Alright, so that's kind of how I like to do those.